Good morning to all. This is in continuation with the previous session. Now in this session we are going to start problems on Fourier series. One question will be given in examination, one full question. So far there are no A and B parts in the given question. One full direct question for 14 marks will be given in examinations from Unit 2. Unit 2, the focus will be mainly on problems on Fourier series. Now let us start all these problems we are going to solve in these sessions. Now first let us consider all examination, whatever the questions they are repeated or being repeated in examination. First we will focus on that one. Let us start. Now, in this session, we are going to begin with problems on Fourier series. Problems on Fourier series. Again, I am giving you a reminder, one full 14 marks question will be from this second unit. Now just look at. As per the Fourier series, in the previous case, we know that any signal that can be written in the format of half A naught summation half A naught plus summation n is equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. This is any signal can be expressed in terms of trigonometric series. That means any function can be expressed as periodic signal. Any signal can be expressed as periodic signal. Where what is A naught? A naught is between the given period t between minus t to t or 0 to 2t. Otherwise 0, here it is 2t. Both are same of the given signal x of t dt. And again an is equal to 1 by t integral minus t to t or 0 to 2t x of t into cos n omega naught t dt. And again bn is equal to 1 by t integral minus t to t x of t into sin n omega naught t. Already in one of the previous sessions we discussed this. One important point is that function or signal, if any given signal that is equal to even, the signal can be odd. For odd signal, a naught equal to 0, an equal to 0, but bn not equal to 0. For even signal, a naught not equal to 0. Not equal to 0 means you have to calculate A naught. An not equal to 0, you have to calculate, verify, but Bn equal to 0. Look at this one. These two are important points. No need to calculate all the three coefficients every time. Before solving any problem, let us verify whether the signal is odd or even. Here, even means you have to calculate only A naught and An, but not Bn, Bn 0. In case of odd signal, we have to calculate only Bn. These are the principles. Now just we are following in the next problems. Now, let us verify. Now let a function x of t equal to t between 0 to 2t. Any function is given like this. That is period. Verify. This Fourier series, now just we have to, a signal is given to us. Now we have to express this in terms of Fourier series. Okay. Now let us follow. Now just look at first one. Here x of minus t is equal to minus of t. Replacing t by minus t. T by minus t means this is called what? minus x of t. So x of minus t is equal to minus x of t. Therefore, the given signal x of t is equal to what? It is an odd signal. First, I have to verify this. It is an odd signal. Therefore, the actual Fourier series actually for odd signal, what happens? A naught equal to 0, an equal to 0, but bn not equal to 0. Therefore, Fourier series, the Fourier series for the given signal x of t is equal to a naught equal to 0, an equal to 0. Therefore, the formula is n equal to 1 to infinity bn sine n omega naught t. This is the formula. Now, in this formula, just we have to find the value of bn. What is bn? Bn equal to 1 by t, the given integral 0 to 2t x of t into sine n omega naught t dt. This is equal to 1 by t integral 0 to t. X of t means what? T. X of t means what? T times sine n omega naught t dt. Now just look at, this is in the form of UV method. This is equal to 1 by t. Now UV method, take t as constant, integrate sine function. For sine, the value is, minus cos n omega naught t by n omega naught. Don't substitute the values now, at the end you substitute, minus integral, take the part as it is, the part here. In this part it is minus. This minus will be multiplying with minus, minus plus. Therefore, we will get cos n omega naught t by n omega naught t, n omega naught t by n omega naught into, for differentiation of t, 1 with respect to dt between the limits 0 to 2t. 0 to 2t. Now, this is equal to, now here n omega naught is constant, minus is constant. So, this is equal to 1 by t minus 1 by n omega naught into t times minus this minus by n omega naught is constant. So the remaining one is called what? Minus cos n omega naught t. Now plus integral of cos n omega naught t. Integral cos means what? Sine. This becomes plus sine n omega naught t by, already n omega naught is here. Again we are integrating, another constant will come. So this will become n square omega naught square between 0 to 2t. Actually in the examination problem, 2 was not there. I given only, in the examination problem there was only between 0 to t only. In the examination problem there is only t. So wherever there is 2t, you can make it only t. This is t, between t only. In the examination problem, only t was given. So between t only. Between t. Now, just look at, now substitute 1 by t into minus 1 by n omega naught. Wherever there is small t, Substitute, replace it by uppercase T. Uppercase is time period. Small t is variable. N omega naught plus 1 by n square omega naught square into sine n omega naught t. Now just we know that t is equal to 2 pi by omega naught, and also formula sine 2n pi equal to 0. Another formula cos 2n pi equal to 1. These three formulae are very much important before solving this one. Now whenever we are substituting, wherever there is t equal to 2 pi by omega, this means what? Omega naught is equal to how much? It will become 2 pi by t. So wherever there is omega naught, replace it by 2 pi by t. So this will become 1 by t into minus omega naught is 2 pi by t. This will become minus t by 2n pi into t into. Now so here there is no, here there is no, it is only cos n omega naught, cos n omega naught t, cos n omega naught t. Now this is t into cos, here wherever there is omega naught, replaced by 2 pi by t, this t denominator numerator cancels, remaining is equal to cos 2n pi plus 2n pi plus 1 by n square omega naught square into, here also replace omega naught by 2 pi by t, t in the numerator, t in the denominator will be cancelled. The remaining is called what? Sine 2n pi. 2n pi. Now substitute sine 2n pi equal to 0. So in this part sine 2n pi value is 0. In this part cos 2n pi value equal to 1. Substituting these values here, we will get 1 by t of minus t by 2n pi into t only. Into t only. Understanding? Now this is equal to this t get cancelled. This is minus t by 2n pi. This is the equation value. Value of, what is this value? Bn. Now put the value of Bn in the main equation A. Then what is the main equation here? X of t. Therefore x of t is equal to, given t, this is equal to summation n equal to 1 to infinity. What are the value we got? This value equal to minus t by 2n pi into sine n omega naught t. In the main equation, don't replace omega naught by 2 pi by t. In the main equation, don't replace. You are supposed to replace in the calculation part only. Now here, the summation is for what? From n. That means remaining all are constants. Keep all the constants outside the function. So this is equal to, that means x of t equal here minus constant, t constant, 2 pi constant. We kept out of this function. The remaining is equal to n equal to 1 to infinity sine n omega naught t by n. This is the Fourier series of the function x of t. X of t equal to t. X of t equal to t. X of t equal to t means what? Before going for the Fourier series calculation, students have to verify whether the given signal is even or odd. Once it comes under odd, look at a naught becomes 0, an becomes 0. This much formula is reduced to this much part. This is reduced to formula. Understanding? This is summation where n equal to 1 to infinity. In the interval 0 to t, it was given the same problem, given only once in the university examinations. Okay, here you applied UV method. In the UV method, at last, after calculating keep the substitutions only at the end of the calculation. In the beginning, don't make, you will be confusing. After that, omega t equal to 2 pi by omega naught equal to 2 pi by t. And also sin 2n pi is 0, cos 2n pi equal to 1. Substituting this, we got the value of Bn. Keep the value, put the value in the main equation A. That is the Fourier series of the signal t. So a signal is given without trigonometric terms, but here it is converted into trigonometric series. That is the purpose of using Fourier series. Thank you.